6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. Pounds of thrust, and it has cleared the tower.
Prepare yourself for a world of consciousness. This is
What's going on, everybody? Conley here. Science Night in the morning. Me and Dr. Thomas Schiller here in the house. We're going to be talking about the science of hollow Earth. Is it real? Can it be real one day? Maybe the Earth might want to, just achieve its dream and be hollow on the inside instead of having a core.
It's going to become an emo kid.
Yeah, and its parents just doesn't understand it.
Yeah,
right.
No, it's gonna. Yeah.
So we have Dr. Thomas Schiller, geologist extraordinaire. We're going to be talking about a little bit of the interesting things in our culture. I mean, flat Earth, hollow Earth. Like, is it possible? What does the science community have to say about it? And why should we care? Why should we actually be thinking about these different things on our own planet? Because when you think about it, the planet is giant compared to us, but small in comparison to the rest of the solar system, and even microscopic, like compared to the universe, right? Or our galaxy, right? And so let's think about this. And so let's get to the microscope. Let's start with the microscopic level.
Okay.
So Adam. Mm-hmm. Okay.
And Eve.
And Lilith.
They have nothing to do with it.
Adam and
there
Lilith.
You go, Lilith.
Yeah, no. And Adam. Yeah. Like, tell me what an atom is, what it consists of. Does it have any kind of properties similar to the Earth as we know it?
So everything is made up of atoms. They're the smallest pieces of matter, and they're made up of protons, neutrons, and electrons. That's your high school physics lesson there. Yeah. So everything, all of the air that we breathe, our bodies, everything is made up of atoms. Now, as they relate to geology, atoms make up minerals. They bond together, usually through ionic bonding, covalent bonding, metallic bonding, and they become larger minerals. And then mineral aggregates become rocks. So yeah. That's the quick and dirty story. That's like a week and a half of lecture that I just.
So the Earth is made out of atoms.
Yeah. Well, the Earth is made out of rocks, which are made up of minerals, which are made up of atoms of elements.
Okay.
Yeah.
So that makes me think. I'm trying to just visualize this a little bit, right? That makes me kind of ponder a little bit on those geodes that you find. Mm-hmm. They're perfectly circular, spherical, or not always.
Not perfect. They're close to it.
They're close to it. But the ones that you find typically that are amazing and are hollow on the inside have this almost football type shape, right? Like this kind of curvature to them. Mm-hmm. And then when you crack them open, it's hollow on the inside, but there's like all sorts of wonders, beauty, layers, crystals. I mean, it's a universe, all of it in its own, right? So, and that's consistent of kind of all these, like these atoms, these minerals, these materials that are all like kind of the reason coming together.
The reason geodes look so cool is because they do retain some of that open space inside of them. Yeah. And the mineral crystals that you're seeing growing inside are unimpeded when they're growing, which doesn't usually happen. Like when a igneous rock forms, you have minerals that are forming within a molten medium, lava or a magma, and they're all forming and kind of forming around each other. So they're impeded by that. But if you have a mineral growing into an open space, like if you have a geode, they actually show their crystal form, their external crystal form, which isn't always the same as if you look at a mineral in an igneous rock. So like those beautiful quartz prisms that you oftentimes find in geodes with the pointy tips on them, that's because that quartz was growing into a void space rather than, growing into feldspars and other pieces of quartz and stuff. And it's funny you bring that up because we're talking, one of the myths that we're talking about is Hollow Earth. One of my favorite great, terrible geology movies, I think we've talked about it before, is The Core.
Oh, yeah.
And
I remember The Core.
One of the most ridiculous scenes in that movie, it's not to the extreme of Hollow Earth, but they're down in the mantle, thousands of feet within the interior of the Earth, and they break into a giant geode. You remember that?
Oh, right, yeah.
And it damages their drill, and they have to do a spacewalk or something inside of this geode. Total BS and goofy, but
doesn't
still,
even happen. They don't exist like that.
No,
big.
they're
not that big. They don't get that big.
No, especially not in the mantle. What goes on, even just a few hundred feet within the crust. It's a sort of a mystery to most people because the temperature and the pressure increases to such a high level that rocks and minerals start behaving differently. If you get really deep in the crust, you get metamorphic processes which is almost like voodoo. It's like magic, where it transforms minerals without melting them. It changes the texture of the rock without melting it. So stuff gets weird as you go deeper within the earth, and especially weird when you get into the mantle.
Absolutely. I mean, I was thinking we did the show, drilling into the Earth's mantle. We got a lot of people
I've heard
talking about it.
A couple of comments about it. Yeah, a couple of compliments out in public.
Yeah, it was pretty cool. And something that I thought of is when you take, to us, whenever we go down and we break the mantle and we can learn about it, it looks so still to us, right? It looks like it's just going to be there forever.
Yeah.
But when you take time and you kind of take our own kind of perception of time out of the equation and take a look at the mantle from the Earth's perspective, a million years is nothing. Maybe a mosquito bite would be a million years for the Earth. It's very fluid, almost. It seems like
that's where things get weird. Is we know the mantle is solid. It's not hollow,
right?
And we'll talk about why that is here in a bit, or why we know that.
Yeah.
But we also know that it's mostly solid. It does have molten or partially molten pockets of stuff because we have magma that erupts at the surface. But for the most part, it's solid rock. So even at those elevated temperatures, the pressure is sufficient to keep it in a solid state.
Yeah.
But you mentioned this fluid nature, especially in the uppermost part of the mantle. There's a weird layer that behaves, it sort of flows. It's still solid, but it behaves like silly putty. And it's the layer that the lithosphere, the tectonic plates, move on. So it's still technically a solid. It might be partially molten, but it's one of these things that's hard, even for a geologist who looks at the surface or the near surface to do their science. Imagining something that's thousands of feet beneath the surface that's behaving like a fluid, sort of flowing, but it's still solid. It's kind of hard to wrap your mind around.
It really is. And when you take time out of the equation, I mean, you look at the top of the Earth, and it's just this ever-changing ebb of chaos, Well,
that's the thing, too. The mantle is pretty active. The engine that drives the movement of the tectonic plates, which move anywhere from 1 to 10 centimeters every year, which is about the rate at which your fingernails grow.
Right. Wow.
So it's moving. It's moving at a really fast pace, relatively speaking.
Yeah.
The Earth being 4.5 billion years old, it's moving pretty good. And there's convection going on constantly within the mantle that's transporting heat up to the base of the lithosphere and transporting cold rock back down to the core mantle boundary,
creating dipiers.
Yeah. So there are columns of magma that are isolated that are moving up through the mantle. There are pieces of lithosphere that have broken off and are kind of floating in the mantle. So all sorts of weird stuff.
Yeah. Wow.
And it's the science of geophysics that lets us know the nature of the mantle and all these different things that are happening.
Wow.
And one of the earliest, realizations or discoveries was that it's not hollow.
Right.
It became very clear early on, even before we had seismic tomography and all these advanced techniques. It became pretty clear that it's not hollow.
Interesting.
Simply by the fact that you could register an earthquake that happened on the opposite side of the globe on the other side. It would not be transmitted through the interior of the Earth if it were hollow.
Right, because it would just dissipate.
Yeah.
But there are hollow parts underneath the ground. Like
At
there's
shallow
underground
depth.
rivers.
Sure,
and
yeah.
Like there's, you can go inside and just, it seems like you could go for days, right? Like and walk and explore
Yeah.
underground.
Yeah, that's at shallow depth, and it's because of that you can kind of see how like Journey to the Center of the Earth was written, because when they go down into the hollow Earth, the fictional hollow Earth, they travel through lava tubes. They go to I can't remember, Iceland or Norway, I can't remember, somewhere up there. It's been a while since I read that book.
Some Scandinavian
one of those
country.
places where they've got lava tubes. And they start following these lava tubes down until they reach the hollow interior.
Yeah.
So if you look back at our perspective during those times, it's easy enough to imagine that the Earth is hollow in the interior, or at least there are giant hollow areas beneath the Earth.
You would think, because, from where we're at on top, it's, 6 miles to our outer atmosphere?
Yeah.
Like if we look up, right? It's... what's the diameter of the Earth, like from, like, if you went right through it? Roughly how many kilometers is it from,
So
like,
just
if you
under
were...
13,000 kilometers.
That doesn't seem very far.
No. So that's why we can take drills and drive them down to the core of the Earth.
I guess so. But to me, it just doesn't. I don't know. That's very interesting. Why do we have like the North and South Pole? Like a lot of the theories out. They're not theories. Not even hypothesis. Right? Speculation. We'll say out there. Is that there's these giant holes at the North and South Pole.
Oh, like
right.
where the axis of the Earth would be?
And nobody can get there, and the government keeps people away, and they think the Nazis got in.
Sure.
And now,
that's some serious conspiracy. I'm not even going to call it
creepy pasta.
Yeah. Yeah, there aren't giant holes at the North and South Pole, but there's cool stuff that happens at the North and South Pole. We actually have 4 different poles. We've got geographic North and South, which is where the imaginary axis would come out, where the giant holes are, and then there's the magnetic poles, which are slightly at a different angle from those, where Earth's magnetic field enters and exits the Earth.
Interesting.
Yeah.
Interesting. Huh.
Another indication that the Earth is not hollow, because the magnetic field that Earth generates that we can easily detect and we can see at auroras is generated by the solid inner core, spinning within the molten outer core, forming like a dynamo, generating that magnetic energy.
Yeah.
That wouldn't happen if it was hollow in there.
Why do you think it's so hard to believe that the Earth isn't hollow?
You mean from the perspective of people who think it's hollow?
Yeah.
I think just like other sort of conspiracy hypotheses we've talked about, people have their pet theories that they like to stick to, and it's a lot of make believe and using your imagination, and they probably read Journey to the Center of the Earth and want to imagine that's the case. I don't know. Well,
it is very interesting, and there's a lot of legend and lore too, from ancient tribes, like saying that there's Indian lore talking about certain people that came up from underground, right? And they live inside the Earth,
the troglodytes,
and so. I love conspiracy personally. I love it. I think it's awesome. I think a lot of it does exist, but a lot of it doesn't, right? And it's kind of the Wild West of thought is how I kind of
I think there are definitely some conspiracy theories out there that are more compelling than others.
Well, conspiracies exist. They do. They absolutely 100% do.
And then when you use the term conspiracy too, you also are bringing in the element of some sort of cover up, which is always kind of fun to imagine.
Yeah, I think that gives the people trying to cover it up a little bit too much credit. I've met a lot of those, and that they don't.
Yeah,
I think I could beat them in chess. I'll just say that.
Yeah.
But,
well, if some of these things are actually true, then governments have done a damn good job of covering them up.
Exactly right.
Yeah.
Good
UFO
for them.
Stuff and
you got us.
Yeah.
And
but the hollow Earth is if they're hiding it, then they're feeding us some sort of drug that's making us believe that it's not hollow. It's
those chemtrails, man. It's those
the
chemtrails, dude.
Yeah.
No, but okay. Well, I mean, I've never not really bought into the thought that the Earth would ever be hollow. I honestly never would ever think that it was flat. I mean, come on. You look at, I mean, as above, so below. You can always think of that, like, because a lot of people that conscribe to I don't know, different ways of thinking, right? Can kind of make comparisons, right? And if the Earth is flat, what other thing on the Earth or in nature, even like when you're talking about microorganisms, are flat, just like small little flat discs, right? Like they all have the spherical shape, everything down to the atom.
Yeah, and there's a pretty simple explanation as to why the Earth is shaped like it is, because when it was first forming as this molten blob, as it's coalescing, everything's going to be drawn into the center of it. So the denser
gravity?
Yeah, because of gravity. And so the denser material is going to go to the center, that gravitational force is going to increase, and it's all going to coalesce and solidify into what we call the geoid. It's really not all that close to a sphere. If you look at a true sort of three-dimensional image of the Earth, it's a geoid, so it's kind of chubby around the equator, and it's got a bunch of bulges and lumps on it from how it formed and how it's been contorted over time.
Sure.
So
it's not a perfect sphere. It's a little.
It's bumpy and it's chubby around the waist, basically.
Well, I mean, that brings up another conspiracy theory that I don't conscribe to right now at all. Maps, completely off. If you look at the map, like on anywhere you go, and you look at a map, not even close to what it really is like, because the curvature has a lot, to do with the distance, right?
Yep.
So can you explain a little bit about that and why it's so easy for people to believe in a map and that's true, but also why it's so hard for people to believe in hollow Earth or flat Earth?
Well, it's so when generating a map or mapping, especially the entire surface of the Earth, the fact that it's not flat is what makes it so difficult. So in order to take a three-dimensional surface, like the Earth's surface, and project it on a map, you have to flatten it out somehow. So imagine, the best way to imagine it is when you take an orange, especially if you have one of those like little cutie oranges that are so easy to peel.
Oh, they're great.
Even though those are easy to peel, I challenge everyone to try and peel it in a perfect fashion that you could take and flatten out and give me a rectangular map that you can navigate with.
Right.
That's what you're doing with the surface of the Earth. So,
wow. That's interesting to think of it that way.
That's what you have to do. And geographers who've figured out different projections, there's not one that's better than the other. There are different projections that have different uses, have really brilliantly figured out ways to take the spherical or the geoid and project it onto a flat surface. So like, if you had a perfect three-dimensional globe that was the same dimensions as the true Earth, that would be the best way of seeing, the distances between things. But you're still measuring distance in a curved fashion.
Sure.
It's not linear. If the Earth was flat, it'd be super easy because you just stretch out a measuring tape, and that would be it. But it's not. It's curved.
Yeah.
So like modern GISs, Geographic Information Systems, have to factor that in, and they use these different types of projections. So whether you're using like a state plane projection on the scale of maybe a municipality or acreage or something, or universal transverse Mercator scale and projecting the whole surface of the Earth in different zones, it's really brilliant how they've achieved that, and there's going to be some degree of error, That's just how it goes. But now we've got GPSs, which are even more brilliant that can tell us our exact location. So the old school maps that you're seeing are really, really impressive, considering that they didn't have satellites
Oh, right.
And they were taking data, they were taking notes from people who were sailing across the ocean with alidade tables and sextants and taking that and producing some maps that were pretty damn close.
Yeah.
Right.
Yeah. That's okay. All right. Well, it's like a kid, drawing with crayons going to turn into Bob Ross one day,
Yeah.
Like, so, I mean, it's good to start, right? And it's cute, but it's not something I think we can, as humans in society can understand, okay, this really isn't like accurate, right?
Yeah. Well, they were doing the best they could. With
Yeah,
what
no,
they had.
I understand.
Yeah. And it's impressive, and that's how science works. You don't start out with an answer to your question. It's a process.
Yeah.
And most of the things we know, including the nature of the Earth's interior, and that it's not hollow, is you're talking years and years and generations of scientists who've put in lifetimes of rigorous work to make those discoveries, and
even works with no end to them. Like, like they came to the conclusion that nope. Okay, well,
yeah, there
lifetime.
are null hypotheses out there for
Yep.
sure, but that's one of the frustrating things about these sort of fringe pseudo-science theories or conspiracies or whatever you want to call them. Is the people who espouse them don't put in the work, and they'll sit there and they'll criticize scientists and try to sort of defame scientists to the extent that others kind of buy into their
because they're very loud.
Yeah, they're loud and they're convincing. A lot of them are convincing. A lot of these people are, they're articulate. They sound like they know what they're talking about. A lot of them are to some degree educated. Some of them are really educated. So some of them have British accents, which helps. So if you have all that going for you, and especially if you're operating in a time where people are skeptical of science in general, it's kind of the perfect storm, the perfect combination to discredit people and get your own pet theories into the public.
Sure. And you know what? Honestly, just from an armchair kind of scientist myself, I just love thinking in general, and I love imagination and to dream. And it just makes the world so much so much more interesting when you can kind of not just rule it out completely, but give it just a tiny little grain of possibility, right? Like,
you'll find that most scientists are like that too.
Yeah.
You don't, especially in my field. There's quite a bit of imagination that goes into what we do.
Yeah.
You're having to imagine how things lived millions of years ago based on limited information.
Yeah.
And I bet you if you were to survey scientists, you'd find that most of us go home and crack open a sci-fi book or something.
Sure.
We're reading Dune or one of these crazy sci-fi novels because we still like to have that imagination.
Yeah.
And that's why it's called science fiction. But there's a big difference between that and what is science
fantasy
fact. Yeah, fantasy and science fact.
And that's always my debate. I will never consider Star Wars science fiction ever in the world. I always consider Blade Runner, absolutely.
I would consider Star Wars to be fantasy more than
it's
science
fantasy.
fiction. Yeah,
the princess and all this stuff. But in some schools, they'll try to teach you in film appreciation that Star Wars is science fiction. It's just not the case.
Sci-fi.
It's just not sci-fi. No. 2001, Planet of the Apes, even. Sure, that's science fiction. But Journey to the Center of the Earth.
Yeah,
science
probably
fiction.
One of the greatest. Yeah.
So
those of you who are listening, if you haven't read Journey to the Center of the Earth, you must read it.
Does it have any kind of science fact?
It does. Yeah.
Okay.
Yeah. So when they're talking about the lava tubes and the composition of the volcanic rocks and all of that, the animals that they're describing when they make it to the center of the Earth are plesiosaurs and pterosaurs, things that had been recently discovered and described during the time. So,
wow.
Yeah, and most good science fiction writers do their research.
Yeah.
So it's still science fiction. It's still fantastical, but there's enough sprinkled in to make it convincing. And I think that's what a lot of the fringe people, the conspiracy theorists and all that are using. They're using that appeal to convincing scientific evidence that's kind of sprinkled in with what is really fantasy, make-believe.
Yeah. Well, I mean, it's very boring getting to these real conclusions, right?
It's not, though. That's the thing that's frustrating, too. But I'm a nerd, you know. I'm a geologist, so the fact that our Earth is so dynamic and the interior is made up of these weird materials that that makes sense. Like, you know, in a way, if you take T out of the equation, time, then it's completely different. I mean, it's mind-blowing to think about it. Yeah.
So what is the core, then, to you? Like, is it, if you were to take the anatomy of the Earth, right? You have the epidermis, right? I would think the crust.
Yeah.
Right? And then you have, like, your muscles and your tissue, and that would kind of, be the mantle?
Yeah.
Like,
so
where would you go from there? What would be the bone?
So, the mantle would be sort of most of your body. The most of the volume of the Earth is the mantle. The core is, if we're using the human body analogy, would be like, I guess, the heart,
right,
or your
heart.
organs or something. But the Earth is more of a sort of a mechanical thing rather than a biological thing. So the core is more like the engine, like the dynamo that's spinning inside of the motor. And it's generating the energy that drives plate tectonics.
Is it like a mini sun inside of us?
It's pretty damn hot. I can't remember how hot it is, but the outer core it's iron and nickel. From what we think, it's iron and nickel, so it's basically the densest stuff that we find terrestrially. The outer core we know is liquid, so the inner core is suspended. It's a dense, solid chunk of iron suspended in the center of a molten outer core, and it's spinning in there. And when you take a metal and you spin it inside of
oh my gosh, it's generating
energy. Yeah, and all
is
that,
it endless?
It's not endless. No, it's eventually we're going to lose all our heat, but the sun will probably go supernova before that happens.
Wow.
We're talking a long time in the future. And if
like
Honorbahn
2 weeks from now?
Or 2 weeks from now.
Wow.
But it's generating magnetic energy, and it's releasing heat, and that's heat that comes from the origin of the Earth.
Right.
Heat that formed 4.5 billion years ago.
Wow.
That's being released. So that's what is driving plate tectonics. It's what's leading to volcanoes erupting, everything.
Wow. Jeez.
And that wouldn't happen if the Earth was hollow. If
right.
it was just a hollow, open
and if
core.
it was flat, where are the volcanoes going to come from?
Yeah, exactly. The flat,
and what machine on a flat Earth is going to cause all of this chaos that we're experiencing?
Yeah, the flat Earth thing, I really don't get. Yeah. Because we proved that a long time
and time again.
I mean, Magellan circumnavigated the Earth. He didn't fall off the end, so that should be enough.
There was no turtle.
No, there was no great turtle. No,
man, but wouldn't it be so cool if there was?
That would be cool.
I'd love to.
Yeah, then we'd fit into
say hi to that turtle.
There's a big turtle in Stephen King lore, right?
I have no idea.
Yeah, I think he's got a big world turtle or something in his
world turtle
science fiction. Yeah,
nice.
Yeah, but he was doing a lot of cocaine when he wrote those stories. So.
That's when the drugs kicked in.
Yeah, that was the drug part.
Yeah,
I think they always kicked in. If you read some of his stuff, holy cow!
Jeez, man.
But my gosh. Yeah, not flat, not hollow.
Not flat, not hollow. Science has. It's funny though when you think about it. Science is wrong sometimes, and it kind of proves itself wrong time and time again. Like, I'm a huge fan of Graham Hancock. I mean, I emailed him, like, he wrote something in a book that I bought, a nice personal message to me. Really, really nice guy. A huge fan of his, and I love the way he thinks because he really just begs the question, right? Are we, as a civilization, he's more of the archaeology, right? And it kind of mindset, right? And are we older than we think we are, right? And we're a species of amnesia, right? But there are these truths that, like dinosaurs, we're digging these things up, and we're dating them. Yeah. Right? Like, not taking them out to dinner or anything, but we can, use this technology as an extension of senses. Yeah. And
there are people who are still skeptical about the provenance of dinosaurs. There are people who legitimately think that they've been put in place by scientists to disprove the Bible.
You got to be kidding me!
No, that's a thing that's out there. Some people think that the commies put them out there. Yeah, that's also when you really start digging into the stuff, it gets pretty wild. But
wow,
yeah,
that's unbelievable.
I don't want to get into Graham Hancock too much, but I do have some issues with the way he goes about doing things. Him and what's his friend's name?
Randall Carlson.
Randall Carlson. Yeah,
Randall. I like Randall too.
So yeah, they're both charismatic guys. They seem nice enough. They're passionate about what they talk about. But here's where it gets me sort of frustrated, and I've gotten angry listening to them before.
Wow.
Especially recently because the younger Dryas we've talked about before, going back 6 years ago, 5-6 years ago, it was one of these things. We've discovered that the Dryas plant is at latitudes that we didn't think it should be, considering the last ice age, which is cool. And since then, there have been other discoveries that point to a big impact. Maybe not even a terrestrial impact, but a sub-atmospheric explosion from a meteorite that may have changed climate for a period of time. Yeah, which is all well and good, and that's something that scientists were hypothesizing about when the Younger Dryas was first discovered. Right.
Mm-hmm. Well, that is scientists, like the scientific community, can be so brutal. I mean, insanely brutal, cannibalistic in some ways. Sure, with their own, in their own cult, right?
Well, that's one of the things that's frustrating about Hancock and Carlson is that's the idea they're trying to promote, and that does go on, for sure. But scientists don't do science for the most part to be that way. Yeah. We're doing scientists because we're motivated by the same curiosity that motivates Randall Carlson and Graham Hancock.
Sure.
So if you look back to when Younger Dryas was first discovered and described, that was a legitimate hypothesis that emerged from it, right? Because there are only so many ways you can heat up the Earth to the extent that you're going to have massive melting of ice, changing of the latitudinal position of subglacial plants. Mm-hmm. So that was a legit hypothesis. And I'm using the word hypothesis because scientists always have to go by the data that are available.
Yeah. And for our listeners, Younger Dryas means Little Ice Age.
Well, no, it's Younger Dryas means there's two phases where the Dryas plant occupied a latitude. The Dryas plant was a subarctic plant. So it indicates it's used as sort of a geographic proxy for the position of global ice.
Really?
So if they find it further south, that indicates that global ice was at further south latitudes, indicating a glacial period. Mm. So the Younger Dryas, there are two periods where the Dryas are at this latitude. The younger one was previously unknown, then they discovered.
Okay, so that's how they came up with the name on it.
Two phases of glaciation, one younger than we previously thought.
Gotcha.
Okay.
Gotcha. I've always heard it was described as like the Little Ice Age.
Yeah, essentially. Yeah.
Okay.
But the Dryas is for the Dryas plant.
Oh, cool. I didn't know that. That's neat. Huh.
But anyway, the impact is a legit hypothesis. They just had to seek out evidence of that. And they did. Mm-hmm. Just like anything, probably teams of scientists went
a lot of
and worked hours and hours. Mm-hmm. Who wasn't doing the work? Randall Carlson. Yeah. Randall Carlson was taking pictures of himself in front of glacial features that we knew were glacial features up in the northeast of the U.S. and saying, I have evidence that a meteorite struck the Earth And it's all tied to Atlantis too, which is the really.
Oh, I love Atlantis.
Everybody
I
does,
love
yeah.
the Atlantis theory.
But it's like, yes, discovered these related to this impact that took place. It's like, okay, he's a tourist. He's out taking pictures. He was like a math teacher.
He kind of introduced his own discipline, sacred geometry, which is pretty cool.
Mm-hmm.
Like I love listening to it.
Yeah,
because
they're
it's just
smart
so
guys. I've
interesting.
listened to them. They're really sharp. They're smart. They're well read. But there's a difference between that and
Actually being out on the field doing the.
well, it's not even that. Like, you could go out and you can participate in that. And this is where they try to give scientists this sort of elitist kind of picture.
Mm-hmm.
It's not just going out and doing it. It's the fact that the people who are doing it they probably spent more than 10 years in college studying that specific topic.
One tiny little thing.
They've probably written books and articles on that specific topic, and they're doing the work. They're not doing it so that they can stand on a soapbox and say, we've figured it out, we've discovered it. They're doing it to push forward the science. None of those people's names are ever mentioned when you hear talking.
Yeah, I never thought of it like that. That would frustrate the scientific community.
It's really frustrating. And they're going on big platforms and they're stating 15 years ago, I told everyone, this.
That's a pretty good impression, dude. By the way, yeah.
I'm not going to try to do, but anyway, they go on all these platforms and they say, we figured this out. We've been telling the scientific community all along that this is what happened.
Yeah.
And it's not like the scientific community wasn't pursuing that.
Right.
And then when finally, after, it must
the scientific
it must
community
be in
takes
between the time that you took historical geology with me.
I remember asking you about it.
I didn't even know what it was.
Yeah.
Really.
Uh-huh.
Between that time and now, they've discovered and not totally
It's like 6
confirmed.
years.
Yeah, there was likely an impact. There was definitely widespread flooding, probably from a lake that its natural levees burst and it flooded. So
Wow.
So yeah, we have evidence of that now. The science has been done. We can say that at the very least.
Yeah.
But here's where Randall Carlson and what's the guy's
Graham.
name? Yeah, Graham Hancock step in and they say, well, now we have the scientific community can no longer ignore that there was this massive impact and massive flooding as a result of the impact.
Very good.
And now we know this is what destroyed the earliest human civilization that was more advanced than any civilization that followed. They jump right into that.
Interesting.
So they have their little conspiracy theory that they want to link to the real science, and that's how they achieve.
I've always heard it as Graham begging the question. I don't ever think he's ever said, "Now we know." I think he's always said, "I think we should consider exploring this," and he's been very careful with his words on that. Just playing a little defense here for those two.
He in his documentary, he's very careful with his words. If you listen to him on podcasts, he's not.
Well, I listened to him on JRE.
Yeah, he was. I listened to him on that too, and he was really disrespectful to science. I thought.
Interesting.
And I think he has a goal. I think his goal is to discredit the scientists.
Yeah.
And he did it strategically during a time when people have very little trust for scientists, or at least the people who he can convince because of COVID and all that.
Oh, right.
And he did it strategically to discredit the scientists, so that he can push his Atlantis idea.
That's an interesting perspective.
That's the way I see it as a scientist, you know, and it pisses me off,
Right, I got
you. They seem to be nice guys, and they're smart.
I'm sure if y'all had a conversation, it would be totally cool. Like, because, you adapt. Everybody adapts to whoever they're speaking to, right? There's this conflicts of give and take and adaptation. And if there's not, it turns into an argument, right? Yeah. And then all the barriers go up, and it's not an open-minded type conversation. Yeah. So I like to think that, we can all... agenda or not, everybody has an agenda in one way or another, right? But
science doesn't, is the thing. Scientists can have an agenda, but if they're doing real science and following the rules, then it should be objective.
Right.
And the science surrounding the Younger Dryas and all that, the hard science has been completely objective. But you can't take that and overprint this idea that it's related to human impact that we have zero evidence of, close to zero evidence.
Okay.
Then and I'm fine with Hancock throwing the question out there, wanting scientists to go look for evidence of some major effect that this had on human civilizations.
Yeah.
And it would be really cool to find a human civilization that predated the impact, one that was advanced.
Yeah.
But archaeologists have been doing that for hundreds of years.
Sure.
And there's no evidence. He's got those two megalithic sites that he claims indicate an advanced civilization. But it's just big rocks with pictographs on them.
Is it basalt?
I don't remember. I can't even remember what it's called. But they're cool. They're megalithic sites. They say that the age date they're getting predates the Younger Dryas, but it's not hover cars. It's not.
Oh no, it would never be that. No, I think the argument they were doing was for the time they were more advanced, and maybe they tapped into some kind of other kind of technology than just the physical technology.
Yeah, this was Stone Age people. They could have done that.
Yeah.
Yeah, but anyway, I didn't mean to
no, that's
get off.
Cool. No, we can add the Younger Dryas.
Yeah. Well,
to the
I know
title.
I think you and Sean, when I wasn't able to join y'all, had a discussion about it at some point.
We had to talk about Atlantis. Yeah.
Yeah.
And,
so I wasn't able to join in on that. So
we got to have one with all of us, talking about that. Because, but anyway,
since we're on the topic of debunking,
okay.
I may have talked about this feature before, but there's this really cool geologic feature in North Africa called the Richat structure.
Yeah.
Have we talked about that already? Yeah.
And that's the structure that kind of looks at red flags to where could be Atlantis, right?
Yeah. The Atlantis fringe people point to that as being a possible site, but it's a laccolith, so it's clearly a geologic feature. And these guys like Hancock and Carlson, they've latched onto it, and they claim that it appears to be human made.
Interesting.
And there's salt inside of it.
Yeah,
because of the evaporite minerals that formed when the sea level was higher. Okay. So they're claiming that indicates the flood, and it's the only YouTube video I've ever commented on.
Oh, you commented?
I commented on it. Yeah, this dude went on Joe Rogan Experience and was claiming that it was man-made and that it was the site of Atlantis, and that the scientists are full of it. They don't know what they're talking about.
Yeah,
and there's detailed geologic maps of it, and people have studied it and written papers.
Yeah,
but all it takes is a charismatic person who is articulate and can spout out at least a couple of scientific facts, and people will trust them,
cling on to them.
Yeah,
because they want to believe.
Yeah, it's fun to imagine. Right? Yeah, it's fun to imagine that the Earth is hollow. It's fun to imagine that there's dinosaurs living down there. It's fun to imagine that there was a advanced group of people who lived, pre-Stone Age, that had flying cars and.
Well, I hope one day that I look in a book. Sometime far in the future, I look in a book and I see the source, and I look up the source, and it goes straight to that YouTube comment. That's how we're going to have to source later on. Whenever science is going to have to change out of this old kind of paradigm that it's been doing, and
that's what science does. It's always evolving and changing. That's why it's so cool. We're always discovering new things.
Yeah. And what do you think? What's your opinion of the scientific community as a whole?
You can't really judge the community as a whole. Like I said, there's bad apples, just like anything else. There are people who are just in it for for their own self-edification.
Sure.
They're really true scientists, most of which you don't hear about because they're not
charismatic. They're not they don't know how to run a microphone.
Some of them are charismatic and have podcasts and have dashing mustaches, and they just don't market themselves. They're
right. Yeah,
they're doing science. They're doing what they're meant to do.
They're out on the field.
Yeah.
Cool. So if say it's you teach a freshman class, so physical geology 1, right? 101.
I've got 32 people in my class this semester.
Physical geology?
Yeah, physical geology.
32. And say someone waits after class because everybody has a line to the professor after class. It seems
We'll pretend that's how it is.
I mean, okay.
It's usually
when I was teaching,
people telling me they're going to be absent on Friday.
Oh, right, yeah, or they have a football game or something. Yeah. But I remember getting that a lot too. But I do remember. So say someone comes up to you and they're waiting in line, and they're the last one. They're making sure they're the last one. Everybody else has left the room, and they tell you, Dr. Schiller, I have evidence, real evidence that the world is hollow.
That's happened to me.
Has it? You got to tell the story, man.
I'm not going to say too much because the guy was a geology major, and he left when COVID hit, and he hasn't come back, fortunately. And he was a strange dude, so I could see him like sneaking in through my back window and
what was your response? Like, what was?
I told him it's not, and I explained to him basic geophysics and how seismic waves work, and he was convinced though.
Wow.
And I almost told him it's going to be tough for you to be a geology major if you think that the Earth is hollow.
Yeah.
Because our unifying theory is based on the fact that there's mantle convection that moves the tectonic plates. So it has happened. I've had that happen.
And have you had any flat earths?
No flat earths.
Okay.
I don't think there are that many flat earth people out there. I think it's one of these groups that has
kind of a troll group.
Yeah.
Real loud.
Some of them are trolls. There was that dude who was head of the Flat Earth Society or whatever it was called, who made his own rocket chair and killed himself.
Poor guy.
No,
I bet he paid a lot of money for those pins, the Flat Earth pins that people wear sometimes. Oh man. Well.
So it has happened. I've gotten some nutty calls from people like down in South County from Terlingua too.
Really?
Yeah.
Saying that they've been there?
No, just asking about that sort of thing, and people with rocks that look like dinosaur bones. And
so you actually hold office hours. That's good, dude.
Yeah.
Good job.
I talk to anyone who calls me or sends me an email. I talk to them.
That's cool.
And
man.
I've entertained a number of people who were convinced they had something, and I'm not. It's you have to crush people's dreams when you're a geologist because they think they've got a piece of a meteorite or a dinosaur bone, and they're going to be able to put it on eBay and get $10,000 for it or whatever. Yeah. And the guy has to tell them, no, it's not what it is.
I remember bringing what I thought was a femur, and it was just a concretion.
Yeah,
we do have a mammoth tusk for sure. I know that.
Okay, that's cool.
I'll have to bring that up to you.
The sad thing is that there's lots of dinosaur-bearing rocks that are exposed around Terlingua, especially like in Terlingua Ranch and Agua Fria.
Yeah.
But no one brings me a good dinosaur bone.
Are they mostly like sauropods?
No, it's a lot of a guha formation. There is some javelina, so it's hadrosaurs and stuff like that.
Oh, hadrosaurs.
Yeah, duck-billed dinosaurs.
Okay, cool. Yeah. So no sauropod? You wouldn't find sauropods out there?
You could in the javelina and Black Peaks formations, but
okay.
But those aren't as well exposed as they are in the national park further south.
Interesting. Cool.
But no one brings me a picture. And it's like,
all right,
here's the complete skeleton right here, Dr. Schiller. No, I've got this thing. Is this a dinosaur bone? It's a concretion. Sorry.
Well, good conversation, Dr. Schiller. And anything else you want to tell, like a young aspiring geologist out there?
Come to Sul Ross State University.
Yeah,
we need you.
Be a major.
Yeah,
you know,
go to school,
I tell people all the time about Sul Ross. You know, Sul Ross likes to promote like football and all these sports and stuff. Dude, this area has the darkest skies in Texas. They have the most unique flora and fauna. They have the most abstract and interesting geology that you can ever find in the world. Those are the students that I feel like called here without anybody trying to bring them all in.
That's how we get our students. They're just drawn here by that.
By that, yeah.
It'd be
amazing.
Nice if we could reach out and draw some in ourselves, though.
Yeah. Yeah, no, that's good. And I know that there's an initiative around that right now.
Yeah.
But that's good, man. All right. Well, hey, another episode of Science Night in the Morning. We will see you next week. Thanks for listening to this episode of Science Nights in the Morning. Be sure and follow us on Patreon for exclusive gear and uncut episodes. Check out the latest science articles on our Facebook page and subscribe to us on YouTube and your favorite podcast listening app. And if you got a question, we'll join the discussion. Hit the hotline at 432-217-1983 and record your message. We couldn't do this without you, and thank you so much for listening each and every week. That's Science Nights in the Morning with a K, and we'll see you next time.